All right, so hello and welcome to this Senatron Bubble Leak Tester training presentation. My name is Avdo and I am the Chief Engineer here at Senatron. All right, really quick guys, let's introduce ourselves. We are Senatron and we are an engineering excellence company. We're located in Salt Lake City, Utah. We've been in business since 2008 as Peak-to-Peak Engineering, and then since 2013 as Senatron. We're experts in three main focus areas. First one is vacuum science and technology. Second one is custom fabrication, more specifically polymer fabrication. And thirdly, we're experts in robustly designed and quality engineered systems. So we develop, design, and manufacture laboratory equipment, including leak testing systems and instrumentation. Bubble leak testing systems are one of many of our wonderful products that we make here for you, and which is also the reason for this video. So before I forget, please like and subscribe to follow our channel. Okay, so you may be wondering whether this training is going to be any good if you have purchased another bubble leak tester or if you're using a bubble leak tester from one of our competitors. The answer is yes. This training will help you understand the principles of bubble leak testing, how to operate it, and how to perform the correct bubble leak test on your test specimen, regardless which bubble leak tester you have, whether it's from us, whether it's from our competitor, or whether you build one yourself. So this training will help you understand bubble leak testing. So thank you very much and enjoy this presentation. So the objectives of this training are to do a quick introduction, to give you a notice, to show you the principles of bubble leak testing, what a bubble leak test is, show you the advantages and disadvantages of bubble leak testing, how you care for your bubble leak tester. We will explain vital components of each of our bubble leak testers that we make. We will also explain and show how to correctly perform a bubble leak test, and finally provide some additional information. On behalf of Senatron, thank you. Thank you very much. So if you're our client, thank you for giving us the opportunity to serve you, and thank you for giving us the opportunity to build this bubble leak tester for you. Our goal has always been to be your trusted partner when it comes to quality control and when it comes to seal integrity testing of your products. And if you're not our client, we would also like to thank you because you've taken the time to learn more about bubble leak testing, and we hope that in the future when the need arises, we hope that you will give us the opportunity to look at your project. Our Senatron bubble leak tester is designed to conform to the following ASTM testing procedures. You can actually see the testing procedures here. There's about 6 of them. Also, one big bonus that you have is that this bubble leak testing system can also be utilized as an acrylic vacuum chamber with a pump. And that opens a plethora of additional applications, such as dry, vacuum package integrity testing, altitude testing, degassing, vacuum potting, and etc. Not only can the Senatron bubble leak testing system be used for specifically bubble leak testing, you can also use it as an acrylic vacuum chamber with a pump. Notice, following this training presentation will ensure an effective and efficient operation of your bubble leak testing system. It will also prolong the life and quality of this equipment, and it will also maintain a safe and secure work environment. Please do not misuse our systems because it may result in equipment damage or personal injury. Also, please don't make any unapproved changes or modifications to our system, and please don't pressurize a vacuum chamber. It is not intended to be pressurized. It is only intended to be used for vacuum. We do have vacuum and pressure chambers that we also offer through our website, and you're more than welcome to take a look at them. We will provide a link below this video. And also, legal notice, we're presenting all of our information in good faith and to the best of our knowledge. Any information that we present in this video shall not be legally binding. So the principles of bubble leak testing. A bubble leak tester is a visual seal and package integrity testing method. So basically, the seal defect is detected through a visual detection of bubbles. These bubbles will emanate from the specimen that you're testing as soon as a vacuum is pulled. A bubble leak test consists of two critical steps. So one, the equipment generates a pressure differential, and two, the operator will look for bubble emissions. What happens is that a pressure differential will cause the air to go from a higher pressure, which is inside your specimen, to a lower pressure, which is the vacuum that has been generated by the vacuum pump and the acrylic vacuum chamber. And what happens is that the air will start traveling as this pressure differential is created. It will start traveling from the higher pressure inside the specimen towards the lower pressure. And as the air travels and moves, it will be visible through the detection or through the visibility of bubble emission. A bubble leak test will enable you to actually detect and locate a leak in your test specimen. That is essentially the basic principle. So you generate a pressure differential, and then you watch for air movement coming from your sample of higher pressure to lower pressure. And the water bath essentially is there as a medium to help you see bubbles. If there was no water, you would not be able to see the bubbles or locate a leak. Also, one thing to note is that a higher vacuum will allow for higher flow rates. So as you decrease your absolute pressure and you increase the vacuum, what will happen is that more air will flow from your specimen towards the outside. And that's essentially, due to the way that air travels. The more pressure differential, the more air will travel. So it will give you higher volumetric flow rates and also more bubbles. However, water will also start to boil as the absolute pressure starts dropping below 30 torr. So what's going to happen is that as you start pulling deeper and deeper vacuum, you will start seeing bubbles starting emitting from your water bath, and it's gonna start to decrease the signal to noise ratio. So there's a happy medium. Generally speaking, it's about 15 inches of mercury, which is half of atmospheric pressure, or about 7-8 psi of vacuum. Will give you the best middle ground. Let's talk about the advantages of bubble leak testing. There's about 6 main advantages that we're going to talk about, and the first one is that it is a very cost-effective seal integrity testing method. When it comes to closure integrity, seal integrity, container integrity, this is the best bang for the buck that you can get for the sensitivity that you're getting with regards to this bubble leak test. Next best method is actually a helium leak test, which is several orders of magnitude more expensive, but it's also several orders of magnitude more sensitive, of course. Bubble leak testing is in line with regards to sensitivity as just as sensitive as a pressure decay test, as well as a volumetric flow leak test. The main advantage of a bubble leak test, it is very, very cost effective. The second advantage is that it is a simple and easy leak test. All you have to do is, keep your specimen submerged underwater and pull a vacuum and watch for bubbles, and you are, on your way to detecting leaks. Your quality control can be very, very simple and streamlined with a bubble leak tester. The third advantage of bubble leak testing is that it is a very, very practical leak testing method. So all you need is a vacuum chamber and a vacuum pump and a way to keep your specimen submerged, and you can practically essentially test, and you'll be in business in no time at all. Within a day, you are ready to leak test your packages. The fourth advantage is that you will be able to visually detect leaks, and you will also be able to locate the leaks. Locating the leaks can be advantageous because you can start seeing patterns, and you can also start seeing repeated failures. If you see increased failures, you can start seeing repeated failures, and that can help you narrow down your corrective action of your sealing equipment. So that is always nice because you can detect and locate the leak. Fifth example is that it's a quick sample prep. So this could be An advantage can also be a disadvantage because some samples can need a little bit longer to be prepped, but generally speaking, if it's something simple like like a container bottle, a food bar, a bar that was a package that was made on a flow wrapper, it is a quick sample preps. All you have to do is clean it, dunk it under water, and pull a vacuum, and you are ready to test. The last advantage is that it is a versatile testing method, meaning that you can utilize it on various shaped and sized specimen, whether that may be a pouch, tray, box, vial, bottle, you name it. If it has air inside, and if it is enclosed or closed, you can use a bubble leak test on this sample. Okay, so moving on to disadvantages of bubble leak testing. Number one disadvantage is that it is a destructive package test. For example, even though you don't detect any bubbles, or even though there is no leak and your test is a pass, this is still considered a destructive test. This means that your samples will have to be discarded after the test. Another disadvantage of a bubble leak test, this is a subjective leak testing method, meaning that you have to look for bubbles. This is a visual way of detecting bubbles, and as you know, operators can get fatigued. It's easy to miss any bubbles, it's easy to miss any leaks. The consensus within the bubble leak testing industry is that a visual inspection is about 80% reliable. What that means is that your test is about 80% reliable. However, you can do a 2x100 inspection, meaning that you can perform 2 bubble leak tests performed by 2 operators, and that way you increase your reliability. But then again, it is a subjective, and operators will, if they're doing this day in and day out, may get fatigued and you may miss leaks. So that is a disadvantage of a bubble leak test, and of course of a subjective testing method. Number 3, and I know I said that this was an advantage, but sometimes this can be a disadvantage because you may have to take special steps to actually get a hold of your test samples and to prepare your test samples. Sometimes preparing and handling may become a disadvantage because this is something that is done offline. So as you're making your batch, you have to pull your samples off the batch and then test it. Sample handling may become a disadvantage sometimes. And also the last disadvantage is that bubble emission tests and procedures are specimen dependent, meaning that you will not be able to use a bubble leak test on something that is sensitive to water, or something that you may have porous material, or something where the material that you encased your specimen in is hydrophilic, or if it absorbs too much water, it may alter your results. So this is something to keep in mind. Let's move on to caring for your bubble leak tester. So first of all, warning: it is heavy, meaning that our lightest leak tester, bubble leak tester, is about 40-50 pounds. So please, don't lift it yourself. Use the proper lifting equipment or ask for help. But it is heavy. And please handle it with care. Now, acrylic is also fragile, so this is a fragile, test equipment, meaning that you should take care of it the same way you would take care of, let's say, glass or anything that is susceptible to breaks and scratches and any crazing. So it is fragile, so handle it with care. And also, it can be sensitive to thermal shock. So this is another, it happens rarely, but if you thermally shock acrylic, you may damage the walls or craze the walls. But it is a very, very rare occurrence. You are able to use regular, water from the faucet to fill up your acrylic bubble leak tester, and it will, work just fine. But keep in mind, as you handle it and as you deal with it and work with it, it is sensible to thermal shock. And also, one last, and this is a warning and attention: please do not use or apply or expose acrylic to any solvents, any thinners, anything that may solve or thin or any alcohols, because after a while it will start crazing the walls and essentially frosting the walls after some time of use. So that is something that is common to all acrylics, and it is something that you should also take care of and pay special attention to. Also, if you have a rotary vane pump, also be sure to check for oil levels. Make sure that the pump is properly filled. So you can essentially, there's an oil level indicator on the bottom, and just frequently make sure that you check it. If you're a large manufacturing plant, you may want to put your bubble leak tester on a preventative maintenance on a PM schedule to properly take care of it and make sure that it's fully filled up and that the oil looks nice and clean and clear, and not bubbly, milky, or too dark. That's one thing if you have a rotary vane pump with your system. If you have a Venturi vacuum pump, that type of a pump does not need maintenance. It is essentially just connected to air. The moment you open the valve, it'll start pulling a vacuum because it is air-powered vacuum pump. And thirdly, we also offer oil-free vacuum pumps, and they don't need any preventative maintenance because it's an oil-free, but you also are advised to perform periodic checks. Check the pump, make sure that it looks good, do a outside visual inspection of the pump, of the system. Take care of it, because this system can last you a long time, years and years. Even though an oil-free pump does not need much maintenance, or a Venturi pump does not need much maintenance, does not mean that you should just set it and forget it. You're always advised to just periodically check it to make sure that your system looks good, that the pumps are working well, and that you're able to perform a good leak testing system. We need to mention something. Every one of our leak testing systems comes with a vacuum pump protection valve. And basically what that is that in case, and this has happened in the past, where the operator will overfill the bubble leak tank with samples, and the moment you close the lid and pull a vacuum, the water will expand, the samples will expand, and they will push the water from the tank towards the vacuum line into the pump. And so one way that we were able to protect the pump is to have a vacuum pump protection valve. And the way it works is that as the water comes in the vacuum pump, it will start filling in this tank. And this pink ball looking ball is going to start floating up, and it's going to close the valve as soon as this cup gets filled with water. And it's going to close, and so it's essentially it's closing off the vacuum pump to protect it from any water going in. So sometimes what you may notice is that you come back, let's say like first thing in the morning, you try to run your system, everything looks good, you hear the pump running, but for some reason it's not pulling vacuum. And what might have happened is that the person before you, or maybe even you, accidentally overfilled your acrylic vacuum chamber, your tank, and you pushed some water into the vacuum line. What you should do is you essentially you can unscrew this cup, dump the water, and don't forget to place this ping pong ball back into this cup to essentially protect your pump from any future accidental overfillings and water in the vacuum line. That is something that we wanted to also make you aware, because it is a important vital part of the vacuum pump, and it's a protection valve. So all right, so moving on. Also, caring for your vacuum chamber. There's two methods that I would advise you to use if you need to clean your vacuum chamber, because sometimes water will deposit a lot of water stains on your chamber. One is the Novus No. 1 acrylic cleaner, and number 2 is essentially soap, damp cloth with the soap, lint-free cloth with this, essentially just soap water. Make sure it's not a bacterial soap, because those have alcohol in it and they're solvents, and they may attack the acrylics. So just regular hand soap will do, and essentially just spray it, you clean it, and you should be good to go. So that's how you would clean your acrylic vacuum chamber. Let's talk about the critical components that are part of every one of our bubble leak testing systems. So you have the acrylic vacuum chamber, you have a drain valve, you have a table frame structure framework, and then you also have a vacuum pump. And this is pretty much self-explanatory. Every single system, every single tank is going to have a drain valve, and this drain valve is used to drain the water from your tank after you're done, doing a testing into, let's say, a bucket, or you can connect a barb, a stainless steel barb, and you can run the water out to, let's say a drain or whatnot. So let's move on. So there's also some other critical components, which is the venting valve. And the venting valve is used to essentially vent the vacuum out of your chamber. Another one is the vacuum gauge, and which is a dial vacuum gauge, which will show you roughly where you are and how high your vacuum is. It is a dual gauge that shows in inches of mercury and kilopascals. And so essentially it will show you if this indicator is in the middle, that means your middle vacuum, and so on and so forth. Keep in mind that the maximum vacuum you can achieve is altitude dependent. So if you're sea level, you're going to be able to reach 30 inches of mercury. If you are, say, above sea level, like we are here in Salt Lake City, about 1,200 meters above sea level, the maximum vacuum we can achieve is about 27, 26 inches of mercury. And this is essentially our cylindrical, bubble leak testing system. So they're both, you can do rectangular, cylindrical, or anything else that you wish. And then there's also, let's talk about the venting valve, let's talk about the vacuum valve, and let's talk about the vacuum adjustment valve. So the vacuum adjustment valve, which is something that we have added to our most recent bubble leak testing systems, and basically what it is that you can adjust the amount of vacuum that you are looking to pull from your vacuum chamber. So if you essentially connect it to our vacuum pump and pull it, you will be able to pull as high of a vacuum as your pump will go. The rotary vane pump will go 29.9 inches of mercury. Our Venturi vacuum pumps will go to 27 inches of mercury. Our oil-free vacuum pumps will go to about also 27, 28, sometimes 29, depending what pump you get. But you essentially will be pulling full vacuum, and sometimes you don't want that. Sometimes you want to set a vacuum level to a certain value, such as you want to go, let's say, 15 inches of mercury, 15. And so what you need to do is you need to open this valve, and then you need to adjust this valve. And as you adjust this valve, you start pulling vacuum. This dial indicator, if you're in full vacuum, will start throttling back until you get to about 15. And then all you have to do is just lock this setting. Let us quickly move on to the modes of operations between the vacuum valve and the venting valve. There are a total of 4 operational modes, whether the valves are on or off, and that will determine the condition or whether you will be pulling, evacuating, or holding a vacuum. So first off, if both valves are open, and assuming your vacuum pump is running, you will essentially just have a continuous run. The air will flow into your venting valve, and it's going to be pulled into your vacuum valve straight into the pump. So this is simply going to be a continuous run. There will be no change in absolute pressure inside your vacuum chamber. The second mode of operation is when the vacuum valve is closed and the venting valve is open. So vacuum valve closed, venting valve is open. What this means is that this chamber will be equalized to the outside air pressure, meaning that if you have a vacuum, you will now be venting your vacuum chamber. The third mode of operation is if both of the valves are closed. So if you have your vacuum valve and your venting valve that are closed, this means that the vacuum or pressure inside this chamber will be hold. It is going to be steady state, and it will stay the same. The fourth mode of operation is when the vacuum valve is open and the venting valve is closed. If the vacuum pump is turned on, what will happen is that the vacuum chamber will be evacuated from air, and you will start pulling vacuum, and your vacuum levels will increase inside the chamber. Each and every one of our bubble leak testing systems comes with a lid clamp. So you have two lid clamps. As you close the lid, you can clamp this lid. Other systems, which we do not make and we don't manufacture them, they don't have this clamps, which means that the operator has to lean on the lid to generate a vacuum. And sometimes this may not be the most ideal situation, because you want to make it a hands-free operation. You want to close the lid, clamp the lid, and you essentially want to operate your chamber. And then another component is the package restraining mesh. And basically what it is that this package restraining mesh will keep the sample submerged underwater as you pull the vacuum. Because if you, let's say, have a candy bar or food bar, when you pull a vacuum, this candy bar will expand and it will start floating towards the surface of the water. And if you don't have this package restraining mesh, it will just float to the surface and it will not be kept submerged, and which means that you will not be able to see any bubbles if there's a leak. So that's something to keep in mind of. Every single one of our bubble leak tests comes with a package restraining mesh, and this mesh is also adjustable, and you can essentially remove, and you can make this mesh as long or as short as possible, or even remove it. So this is another nice thing that we do for our clients as well. It is a removable package restraining mesh and adjustable. All right, moving on to our critical components. We also offer feed-through ports that you can use to connect any pressurized air that you would like to run, or any liquid that you like to run. We have had clients use penetrant, it's a dye penetrant, so it's a dye that they connected to their system, and then they pull the vacuum, and then the dye would essentially penetrate and flow through the leak, and so you're able to see the dye. Others have used essentially pressurized air, where they pressurize the samples to provide them with additional pressure to see better, to see the bubbles better, because some systems may not have the highest volume, meaning that you need to continually feed it with air in order to detect a leak. And then we also offer a quick release mechanism, quick release vacuum gauge mechanism, and this is used so that you don't have to unscrew your vacuum gauge. You can essentially release it, and you can send it to calibration and then quickly put another replacement gauge on there, so you will not be stopping production while your vacuum gauge is getting calibrated. So that's another option that we offer as well, and you can see more info on our website. Let's talk about how you can perform your bubble leak test and how to correctly perform your bubble leak test. The first thing you need to do in step one is you need to place your bubble leak tester on a good surface, on a good working area, and then of course lock the casters, or if you don't have casters, so place it on a good surface that is solid, and that will allow you to actually operate your bubble leak tester. And then the second step is that you need to connect your vacuum pump to electricity, of course, plug it in if it's an electrical vacuum pump, and if it's a Venturi vacuum pump, then connect it to air, right? So plug it into air, make sure that you're fully powered and initiated on your vacuum side. And then what you need to do is you need to close your drain valve, of course. Make sure that your drain valve is closed, because obviously if you start filling in water, which we'll do in step 4, you're going to start dumping water on the bottom, and you don't want to do it. So close the drain valve and fill your acrylic vacuum chamber with water. Regular tap water will work. Hot, cold water, it's fine as long as it's within room temperature. Don't overfill your tank. So this is something, it's going to require some trial and error, but don't overfill your tank. because you don't want to refill it, because you don't want to risk getting your specimen your water being pulled into the vacuum pump. And then also what you need to do after that, once you have the correct water level, is you load your vacuum chamber with your test specimen. So you place your test specimen, pouches, bags, tanks or whatnot, bottles, you place them inside your water. And then what you need to do is you need to close your lid. And as you close the lid, again, observe your water level, make sure that this is not fully filled up to the rim, because it will pull the water into the pump. Close the venting valve. You see on this chamber it's on the left side. Remember on the other images it was on the right side. You close this venting valve, and then what you need to do is you open, let me go back here, you open your vacuum valve, or you can sometimes turn on the vacuum chamber while the vacuum valve is closed and then open the vacuum valve. As your vacuum is being pulled, what you need to do is, adjust it if you haven't adjusted your vacuum level. If not, you can just essentially keep this closed and you go maximum vacuum, but you adjust it to your desired vacuum level. Once you have that adjusted, or if it's already been adjusted prior to your using it, then you should be okay. Keep in mind, you will start noticing water boiling if and you can kind of, I don't know if you guys can see it, but on this one it's not happening because the vacuum is not high enough. But you will start seeing water boiling. If it does boil, then you may have too high of a vacuum, and your signal to noise ratio may also be too low, and may not be the most practical way of detecting bubbles. But it's something to keep in mind, and we talked about it in the previous slides. Once you reach your desired vacuum level or your specified vacuum level, you can close the vacuum valve and hold the vacuum and then look for bubbles. Sometimes your specimen may not expand. I mean, this is a food bar, candy bar, I believe it's a food bar, so it does expand, but others, they may not be expanded because it may be rigid container. But in any case, so you start look for bubbles and start detecting, and bubbles you will start see a constant stream of bubbles coming and rising towards the top. So depending on the leak size, they may be easy to detect in one instance and a little bit harder, and it may take you a little bit longer to detect it in another instance. Basically what you need to do after you're done with the test, finally what you need to do in step number 14 is that you need to close the vacuum valve, and then you need to open the venting valve and you let the chamber vent. And an additional step that you can do is you take out your test specimen, you can open the pouch, and then you can look for water or liquid inside your pouch or container. But that is, of course, after you've properly dried your specimen, after you've taken it out of your bubble leak tester. Because sometimes bubbles may not be emitted, but water may have gotten into your test samples, and that also indicates a leak. That's another tip that you have. And then, of course, you want to record and note your test results. All right, so let's talk about a bubble leak test that we performed at one of our customers' manufacturing site with actual samples. So let's get started. As you can see, we have already loaded our test specimen inside the chamber, which are being pushed by the package restraining mesh that is about 1 inch below the water line. So we already turned on the vacuum pump, and we will close the venting valve, and the chamber will now get evacuated. Vacuum will be pulled, and the samples, as you can see, will expand a little bit. At this point, we're using about 8 or 9 inches of mercury for this vacuum setting that was set up with this vacuum adjustment valve. Sometimes you can go up to 15. This particular test was used at about 8 or 9 inches of mercury, and we did not see any leaks, so this test is a pass. Well, so this concludes our training video. First of all, I would like to thank you for sticking with us through this training video, and thank you very much for paying attention, and thank you very much for giving us your time. Please don't forget to like the video and subscribe to our channel, because we release from time to time very, very informative videos that are informative and entertaining, and that will help you with regards to your leak testing, as well as with regards to learning more about vacuum technology. If you have any questions, please post them in the comments section. And if we receive a lot of questions, we will make a follow-up video on this bubble leak testing training video to answer any of these questions. And we will also answer your questions, anything that you post in the comments section. Just don't forget to contact us, call us, email us if you have any question. Our information is of course on our website, and it's also posted on this channel. So thank you very much, and you have a wonderful day.